with more sodium and more water, what happens to our venous return? Remember from our blood pressure lecture? Venous return goes up, end-diastolic volume goes up, stroke volume goes up, cardiac output goes up, blood pressure goes up. That returns more the overall effect than occurs. Okay? However, if we reabsorb more sodium, what are we going to do? We're going to lose more potassium. Okay? Some diuretics block the effect of aldosterone here, and they prevent the sodium from being reabsorbed. So more water stays in the collecting ducts, and your urine output goes up, which is what a diuretic does. Okay? So if we're not reabsorbing the sodium, what are we keeping? Potassium. Because if we're not taking the sodium in, we're keeping the potassium, because remember that's an exchange. So for some individuals, this can be dangerous. All right? It can elevate their levels of potassium, which is not good for their heart. And so there's, again, a physician would look at various types of diuretics that might lower blood pressure without elevating potassium. The cells that have receptors for aldosterone are identified as principal cells. Tomorrow we're going to talk about intercalated cells. And so found in both the distal tubular and collecting ducts, we have intercalated cells, which are pH responsible. We'll cover that in lecture tomorrow. But both regions show principal cells. And the principal cells have internal receptors for aldosterone. They also have receptors for antidiuretic hormone. So antidiuretic hormone is going to affect the aquaporins. Antidiuretic hormone and aquaporins go hand in hand. So here's the G protein hormone. Anybody remember what part of the body synthesizes antidiuretic hormone?
Bathroom.
Excellent. No, you might have thought it, but nobody said posterior pituitary gland. Posterior pituitary gland releases hypothalamus, but the neurons that synthesize it are actually in the posterior pituitary. Okay, so remember we have the nuclei of the hypothalamus, and its axons actually go into the posterior pituitary. So it binds to its receptor in the basal lamina of the principal cells, all right? Activates through G protein cyclic AMP. Cyclic AMP phosphorylates the enzymes necessary for activating the aquaporins. They're already synthesized, so it doesn't take very long for that to happen, okay? And they become inserted into the membrane of the principal cells. Now this is not quite correct. It just shows the water passing through the phospholipids. It actually requires a water channel, and that's what the aquaporin is. Yeah. Now, so what's going to happen to urine output if we have those aquaporins inserted? Let me go back here where I could put in. May I erase this part here of the angiotensin?
Decreased urine.
Oh wait, oh those.
Sorry?
Yeah, I'm done.
Okay. So if I pull my collecting duct back out of the cortex here, and we have these receptors for aquaporins in our collecting duct. If ADH is present, then water will be taken out of the collecting duct via the osmotic force of the concentration gradient. So again, if I drank 2 gallons of water this morning, Would I have any ADH being secreted? Would I need aquaporins in my collecting ducts? No.
You need.
So my aquaporins would be absent, and the osmolality of my filtrate would be at that 100. No, the osmoles.
I know, it smells like a
Probably
party.
something from the outside, over there on the opposite side of
It smells like a
microbiology.
match.
We get that. Somebody's smoking up there, whatever. Okay? If I haven't drunk very much, then I would need more water. I'd be releasing ADH. Water would be being pulled out. Okay? Now, the effect of aldosterone, taking sodium and then a few water channels to allow water to follow, what is that going to have on what effect will that have on the osmolality of my blood? If I have both sodium ions and water returning to my blood due to aldosterone. Obviously my blood volume would go up, but what about osmolality? It'll stay about the same. Now if I have only ADH, am I taking sodium back into my blood? No. I'm taking water. Okay? One of the case studies for this unit that wasn't picked up was a new one that I put in a year ago. My father-in-law was in the hospital once again for pneumonia, and my sister-in-law called and said that Dad was confused, he couldn't hold a conversation. When you talk to him, he couldn't pay attention to the TV and the conversation at the same time. He wasn't like seeing spiders on the walls or something like that, but he was having a hard time concentrating and so on. And so then she called back and said he had SIADH. And I was like, huh? What's that? And my husband, who thinks I know everything medical, we were driving up to Chico for a basketball game. And I said, well, ADH is a hormone, a hypertensive something or another. And of course, Savannah, the kids had their smartphones, and I didn't have one at the time. And it was like, oh, that's right, look it up. So it's a syndrome of inappropriate secretion of antidiuretic hormone. One of the causes, which fortunately wasn't the cause here, is lung cancer. Lung cancer makes additional ADH. So if you make too much ADH, are you going to have too much fluid in your body or not enough?
Too much.
Too much. Because antidiuretic hormone prevents you from going to the bathroom. So if you have a lot of ADH, you're going to be retaining fluid, right? Hence his confusion. It was similar to high altitude cerebral edema. Because of the ADH secretion, the fluid that he normally would have excreted across the kidneys was being reabsorbed because the aquaporins were being present, and that excess fluid around his brain cells was causing the confusion and the neurological symptoms. Okay? Now, in his case, it had to do with pneumonia, not a tumor. And in fact, the lungs are weird. They do all sorts of things that you wouldn't normally think that they do. All right, so finally, there's a couple of more components on your, what page is it? I've mentioned a couple of hormones on page 30. We've talked about aldosterone. I'm going to mention parathyroid hormone now because another ion that is absorbed, that is reabsorbed, is calcium. That is regulated at the distal tubule via parathyroid hormone. Okay? For some reason, parathyroid hormone is also associated with the ascending limb. You'll see that mentioned, but its primary location is at the distal tubule. And this is where we regulate increased calcium absorption. Remember, the only hormone effect we saw at the proximal tubule was also parathyroid hormone, and that was suppressing the absorption of phosphate. It doesn't really have a systemic effect because it also increases absorption of phosphate at the digestive tract. So it really just kind of cancels itself out, and it's not important physiologically. So parathyroid hormone, aldosterone, ADH, those are hormones that we see affected at this area of the body. The calcitriol that's mentioned there is one of two hormones that the kidney actually makes. You guys remember what the other one is? Yes, the DPO. Very good, erythropoietin. Okay, it's the other hormone. So again, the kidney's an endocrine organ. We don't normally think of it as one, but it is an endocrine organ. It's involved in the formation of actually vitamin, the activation of vitamin D as well. Okay, so let's stop there. Tomorrow we're going to look at acid-base balance. And today, after break, we have, as you can see, I had everybody from the morning lab go pee for me. Not really. Those are artificial urine mixtures. And so we'll be testing some, using some dipsticks to test that. And then we'll look at characteristics of urine, what you're looking for with those dipsticks. Okay, so we'll look at that after break. So, when do you want to take your quiz?